Hello, my name is Pat. I'm with Automated Industrial Systems. This is your instructional video on this ESP1M O-ring machine that you've purchased. It's designed to put O-rings onto this part. Something I should point out is we have a locating pin here to go on the inside of the part. Now, one end of the part is a very clean hole. The other end of the part seems to have a bit of a burr. So we have a good mate up with the one end, and oftentimes we have a little bit of a gap here on the other end. Now, it seems to be transferring okay with a fairly rapid push, and it seems to be making at least most of the way to the up next to the flange, but it doesn't always get up all the way tight. Demonstrate. When you power up the machine, it goes through a single pump cycle. Okay, that ends up tight. That wouldn't happen to go up tight, but oftentimes, it's, depending on how big the burr is, it doesn't quite make it. We've cycled this machine total of at least 750 cycles, and it's doing very well. We didn't have any hang-ups during that test runoff. That's not to say that it can't happen. Every once in a while you get a little flashing or something on an O-ring and it doesn't tend to feed well. It'll get stuck in the track. And we supply you with a pick tool. It's plastic. Has a hook on one end and a point on the other, and if they get stuck in the track, what happens is if it comes up dry on the mandrel with no ring, you've ordered the missing O-ring detection, and the machine will stop functioning. In fact, I'm going to turn the bowl down to 0. There's a bowl amplitude thing on the side. As we're running it, eventually we'll run out of rings. Show you what happens. We have a sensor going across this magazine, this track area, and it monitors the amount of O-rings in the track, and typically when it gets low, then it refills the track, and there's a delay on and a delay off. So a couple seconds after the track is cleared and the eyes can look across, then the bowl would kick on, and a couple seconds after it has been blocked with the O-rings filling up, then it shuts back down. So right now the bowl is shut off and we're emptying it out to the point where it'll miss one coming out. Now, it just missed one. Now, I physically cannot push in on this mandrel. We have a light on the side here, and it says missing O-ring, press reset. There's a reset button right above it. Press that, and we have to figure out why we're not getting O-rings. And in this case, the bowl is turned down to 0, but if you had a stuck ring, then you could take the pick tool and give it a little push, and then once you've got rings, you just cycle it, push it in once. That'll bring a ring out, and you're off and running again. Okay, I want to go over a few things on this machine. The way the prox works here is the missing O-ring detection. It is a prox switch, and there's a set screw on the opposite side of the Delrin jaws here. We have a set of floating Delrin jaws that spread apart as the mandrel is ejected with the O-ring on it. and that we lose the signal when the jaws are spread, so it knows that there's an O-ring on it. If it comes through and it doesn't spread it apart without an O-ring, the signal stays the same and it knows that there's a problem. If it gets... Alright, I've taken the liberty to pull the cover off, and we'll get you familiar with some more items on the piece of equipment here. We have a power switch on this back side. You've got your 230 volts coming in. We've supplied you with two different cords. There's a American cord for testing, and there's also an Argentinian cord for the final destination. We have the regulator here. We're setting it at 65 psi. You see on the control box here, we've got an air switch. We have a counter that's resettable. We have an amplitude adjustment. Now this is a 50 Hertz driver.